Okay, going to do some work on surds here. Just going to start with a bit of a definition of what surds are. So it's mathematical expressions that contain that little sign there. That one there, it's sort of like the square root, but it's not just the square root. It can be a cubed root, as in the cubed root of 8 would equal 2, because 2 times 2 times 2 equals 8. It can be a fifth root, anything. But it's that basic sign there. So examples of surds, mostly you'll see it as the square root sign. Okay, so these are example of surds: the square root of 5, square root of 3, 4 times the square root of 6. Pardon me. And surds can be worked out using a calculator, but the answers are always approximate decimals. Okay, because basically these surds are all irrational numbers. Note, and this is the difference between surds and non-surds. See here, the square root of 9 and the square root of 16 are not classified as surds because they are equal to exact numbers. So the square root of 9 would be 3, the square root of 16 would be 4. So these aren't surds. Square root of 5 is a surd because it doesn't come out to a rational number or a whole number. Okay, so only those square root things that can't be worked out exactly are called surds. Okay, adding and subtracting surds. There's only one rule to remember here. The surds have to be like surds to be able to work them out. Examples, it's a bit like the concept of like variables in algebraic expressions. So in this case, we've got 3 lots of root 5 plus 4 lots of root 5 equals, guess what, 7 lots of root 5. Another example, 6 lots of root 3 take 4 lots of root 3 equals, you guessed it, 2 lots of root 3. 2 lots of root 7 take 8 lots of root 7 equals minus 6 lots of root 7. And 11, or 1 lot of root 11, because there's 1 implicitly there, plus 4 lots of root 11 equals 5 root 11. Okay, these are like surds, and you can do these sums easily. Meaning like surds is you've got a surd there and a surd there, and that number is the same. Okay? Root 5 plus 4 root 3 is just root 5 plus 4 root 3. You can't add them together, you can't simplify it. Same as this one, 3 root 7, take 2 root 2. We can't really do much with that because root 7 and root 2 are unlike surds. Root 5 plus root 3, once again, equals just root 5 plus root 3. We can't, it's not root 15 or anything like that. Or root 8 or anything like that. This plus sign, this is like an x plus y. We can't simplify it, it just sits there. It's as simple as we can get it. So these are unlike surds, and you can't do those sums, or you can't simplify them like you can these. Okay, adding and subtracting surds, continuing. We can get a whole stack of them, an expression with a number of surds, some like and some not alike. In this case, we've got 2 like surds and 1 not alike. These two we can simplify. 3 root 5 plus 2 lots of root 5 it gives us 5 root 5, and the 4 root 7 we just add that in afterwards, but we can't simplify that anymore. It doesn't come to 9 root 12. It just doesn't work that way. Okay, so this is showing you like surds are added together. So in this case, there's 2 like surds, root 3 and 6 root 2. So it's 3 root 2. That's going to give us 9 root 2 take. Now, here's non-surds, and they can be added, 2, minus 2 and 12. So we're going to get 9 root 2, and the other's going to leave us with minus 2 plus 12. That's going to give us 10. Okay. So there's like surds here, 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 there, and there. Okay, first 3 take 8. 3 root 7 take 8 root 7. That's going to give us 5 minus 5 root 7. And these two surds here, these like surds here, minus 5 plus 6 is going to give us plus 1 lot of root 2. Okay, simplifying surds. Some surds like root 8, root 12 and root 18 can be rewritten with smaller surds. So see what that means. It means I can do something in here to this number to reduce it. I'll show you what I mean by that. Example 1, to simplify the square root of 18. Now you notice you can do this particularly when this number in here is not a prime number. Okay, but we'll just go on with this. Step 1, list all the factor pairs of 18. 2 and 9, 3 and 6, and 1 and 18. So what we're saying is 18 can be expressed by either one of these little expressions here, these factor products. Now if you have a look at this one here, 2 times 9, this number here very handily is going to help us because it's a perfect square. Okay. Step 2 is choose the number with the biggest square number. That's the biggest square there, because 3 by 3 is 9. None of these other numbers are squares. 18 and 6 are not squares. So there it is, we're going to grab 9. So we can rewrite square root of 18 equals the square root of 9 times the square root of 2. Okay? Since the square root of 9, sorry, we're going to have to go back there because I accidentally pressed that. Since the square root of 9 equals 3, we can write the square root of 18 equals 3 root 2. Okay, so this, we just write this as 3. 3 times root 2. So we can get rid of, in here, it's implicit that we've got a multiplying. So this statement and this statement are equivalent. So root 18 is the same as 3 times root 2. Okay, a bit more in simplifying surds. Another example, square root of 54. So the first thing we're going to do is once again look at the factor pairs of 54. Going to identify the biggest square. Once again, it's 9. Okay, and there it is there. Choose the number with the biggest. There we go. We're going to choose that one. So I'm going to write next the square root of 54 equals the same as the square root of 9 times the square root of 6. And that's, as we see, because the square root of 54 is the same as the square root of 9 times 6, which is the same as the square root of 9 times the square root of 6. Okay? So, once again, since the square root of 9 equals 3, we can write the square root of 54 equals 3 times the square root of 6. That's our answer. Okay, another last example, example 3. Simplify 5 root 48. So we're just going to first look at the root 48 thing here. We're going to see to simplify this. List all the factor pairs. Okay, which is the biggest square? Well, in this case, it's 16. So we're going to concentrate on that factor pair. 3 times 16 is 48. Okay, 6 times 8, that's not going to help us at all. Okay, so there's the one we're going to choose, this pair here. I'm going to rewrite the square root of 48 is equal to the square root of 16 times the square root of 3. Now, you see the next step, square root of 16 equals 4. So we can write the square root of 48 is 4 root 3. And the final step, put the whole thing together, 5 times root 48 can be written as 5 times 4 root 3, because 4 root 3 is the same as root 48. Now the 5 times the 4, that's just 20. So this is going to finally equal 20 times the square root of 3. Okay, so that's just our first little look at surds. We're going to come back in the next video and continue on.